Good evening. My name is Blessing Agaba, and I'm here to talk about fashion assistant. I'm a student of Makerere University. Fashion assistant will be helping people who lack fashion etiquette and who lack fashion recommendations, and people who actually waste time trying to figure out what to wear. It will be helping people make choices of appropriate clothes for different social gatherings, parties, meetings, etc. And it will choose that according to trend, decency, of course, appropriateness, price, color, description. And I used a data set from cargo.com. And this is, I provided a screenshot of how it will look and how will it be used. It consists of features, which these features, we have the inputs, we have the outputs. And if I go to my Excel here, we can see right here that the inputs include the description and product ID, gender. And of course, if you input these inputs, they will help you provide an outcome. And the outcomes here, there is primary color, there is price, there is product brand, and yeah, the number of images. This, after providing, for example, a description, it definitely has to give you a gender or a brand that you want, and it will give you the product name, it will give you the price, it will give you a color. If you input your gender, it will look for you the appropriate outfit. Basically, that's how my data set will be working. So let me talk more about Bayesian theorem. It is a way to calculate when a condition is given based on another condition, meaning a certain condition has to occur for another condition, for the other condition to occur. It determines the probability of an event with uncertain knowledge. Bayes' theorem finds the probability of an event occurring given the probability of another event that has already occurred, as I already explained above. So we have it is stated mathematically as seen right here, which can be read as probability of hypothesis A when we have occurred and evidence B, meaning B does not have to be zero, meaning B has to exist for A to occur. Basically, we're trying to find probability of event A given that event B is true. PA is probability of A is the prior probability. What do I mean? Probability of the event before evidence is seen, meaning this probability is what occurs before that condition that we base on is seen. And that evidence condition that we will have to base on is the probability of event B. So probability of event A given B is the posterior probability, meaning the probability of event after the evidence is seen, which evidence is probability of B. And then we have naive Bayes. What is naive Bayes? Naive Bayes is a collection of classifications, and it is of course based on Bayes' theorem. It includes multinomial and Gaussian naive Bayes. So multinomial involves a situation where two conditions are carefully calculated, compared, and the higher probability determines and is considered to determine the correct prediction considered. Meaning, under multinomial, you have to have two conditions and determine the one with a higher probability is the one that you will go with. Then Gaussian naive Bayes is a probabilistic classification algorithm based on applying Bayes' theorem. And of course, what do we mean by with strong independent assumptions? This means we'll consider independent assumptions, independent probabilities. We assume that no pair of features are dependent, meaning all the features are independent. Each feature is given the same weight or importance. For example, right here, description, we won't consider the description, and would be like this. The description has more weight since it includes the color, like it tells you the color and the brand and then the name. We will actually make sure to have to give each of these the same weight or importance. So going back, here is a continuation on naive Bayes, and it says it consists of feature matrix and response vector. What is feature matrix and response vector? Feature matrix contains all the vectors of dataset in which each vector consists of the value of dependent features. This is almost similar to what I said above. The values have dependent features, and response vector contains the value of class variable for each row of feature matrix, meaning there is a value that you have to consider to determine the other feature. The fundamental naive Bayes assumption is that each feature makes an independent and equal contribution to the outcome. We assume that no pair of features are dependent. Each feature is given the same weight. I said it above. Yes. So we have the Bayesian networks. Bayesian networks is a key computer technology for dealing with probabilistic events to solve a problem which has uncertainty. A Bayesian network is a graphical modeling technique that is used to compute uncertainties by using the concept of probabilities. It consists of directed acyclic graphs and table of conditional probabilities. I put like an example, though it doesn't apply to my project, but I included the image right here. And Bayesian networks basically consists of nodes and links, and the links show what is directly dependent on the other. Like here we said, to solve a problem which has uncertainties. For example, here in my project, the uncertainty we have right here is price. But how can Bayesian networks solve that? It will consider price. For example, the brand. If you know the brand, at least you can be able to determine the price. If you know the description, you can be able to determine the price. If you know the product name, you can be able to determine the price. Meaning, if the price depends on the description, depends on the product brand, it depends on the product name. And then we have Bayesian networks right here. Explaining more, it is based on joint probability distribution and conditional probability, where joint probability is a measure of two events happening at the same time, while conditional probability of an event so Bayesian networks is based on joint probability distribution and conditional probability. Joint probability is a measure of two events happening at the same time, while conditional probability of one event is a probability that that one event will occur given that another event has already occurred, which is almost similar to that Bayesian theorem above. Joint probability will consider two conditions at the same time, but for conditional probability, you'll have to consider one condition given that an event has already occurred. So what is the difference between Bayesian theorem and naive Bayes? Naive Bayes is simply a classifier, and Bayesian theorem is actually a theorem. Naive Bayes assumes conditional independence, while Bayes' theorem does not. This means the relationship between all of the input features are independent for naive Bayes, unlike Bayes' theorem where the input features are dependent. So for Bayes' theorem, the input features depend on each other. You have to consider each of the features, but for For naive Bayes, you have to, the features are independent. Like you can only consider one feature. That is why it is called naive. And what is the difference between naive Bayes and Bayesian networks? Again, naive Bayes assumes conditional independence. All the features are independent, whereas general Bayes networks will allow a user to specify an attribute, in fact, which is in fact conditionally independent. So for Bayes networks, a user can actually specify which attributes is they are supposed to use that will be conditionally dependent. Thank you for listening.